Yo, 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 yo. People, we are here. What's going on out there? How we doing? Welcome on in to the live stream. Hope you guys are staying warm out there. I got the space heater on full blast back here. It's great. It's great. But today, people, we are going to finish up Unit 5, which means you only have one unit left in all of macro and all of micro. And then our time is over. You know? It's sad. It's sad. But yeah, we're almost there. We're almost there, right? We just have, Unit 6 to do. Public goods, externalities, inequality, right? That's pretty much it. So we're almost done. But yeah. So yeah, we're going to talk about, people. Oh my gosh, Mr. Moore. I didn't update this. Let me do it right now. So first, we're going to talk about the least cost rule, which is just like utility maximization, basically the same idea, but instead of finding the optimal combination of goods, we're going to find the optimal combination of resources to produce at the least amount of cost minimizing. And then we're going to learn about monopsonies, and we're just barely going to touch on monopsonies, right? Like it's going to be all of 3 slides, because monopsony has only been asked one time ever in the history of the AP test. So, in a short semester, right, we're not going to go too crazy in monopsony, all right, by any means. And you guys are going to do that FRQ that was asked. It was 2011 Form B. So you guys will do that one today, and I think if you guys do that, you're better than most, right? You're gonna be more prepared than most students will be, just because you've seen a monopsony before. But yeah, all right. And then have I made? I'm gonna have to check and make sure I made a problem set 4.7 answer key. We'll see. Wait, 4.7? People, when's the last time I updated this? This is crazy. When's the last time I've given you it as an answer key? I don't know. You probably have, but whatever. All right. Let's get to your attendance in the chat, people. Your attendance in the chat today is... Which language do you wish you could speak fluently? I know, I'm kind of slacking, I'm not going to lie. I'm getting burnt out, people. Which language do you wish you could speak fluently? What do you say? There is one major language today that no student has said. It's pretty crazy. No one student has said a major language that they wish they could speak. All right, the results are in. Jacob says French. Nina says Russian. Interesting. Italian, because it sounds cool. Italian. Chinese, I really want to go to China. Italian. You guys are all saying Italian. I'm surprised. Latin. Super useful worldwide, yeah, especially if you're going into into medical school, right? They pretty much, Latin terms are gonna help you out a lot. Oh no, people, I'm back. Russian, you guys are all saying Russian. It's interesting. French, Italian, French, Italian, Russian. It's all this Russian love over here, people. Latin, Italian, or French. Latin would be pretty cool. One of my best friends lives in Italy, so I'm learning it. You are learning it right now? That's pretty crazy. How'd you guys become besties, Tell the chat. And Ariella says Latin as well. Latin is also a very cool language. I want to learn that too. People, I would want to learn Spanish. That's what I want to learn. What is going on with my camera right now? I want to learn Spanish. Because I took French. I took French in high school. Now, I can't speak French fluently by any means, but I can read it pretty well. I think if you gave me some French literature, I would be able to, give you a good little summary on what it is, but there's no way I could hold a conversation in French. But I would love to learn Spanish. I think Spanish is the most beautiful language in the world. I truly believe that, but no one has said Spanish today. Not one student has said Spanish. It's probably because you guys all know Spanish, at least a little bit, right? You guys have all taken classes on Spanish, right? You're probably tired of doing schoolwork. German would be pretty cool to use. Yeah, I want to learn German too, because sometimes, like me and Hans, we can't communicate. We got a little language barrier going on. So if I learned German, I probably could, me and Hans could converse a little bit more than we usually do. We played basketball together. She went to school here as a foreign exchange student last year. Ah, I gotcha. That's kind of weird. I was actually really good friends with a foreign exchange student when I was in high school, and we were friends for a long time. We haven't really talked in a while, but in college and stuff, I went out to Germany and visited my friend. It was pretty cool. Yeah, Hans speaks German. Yep. Of the 85 words that he knows, about 10 to 15, I think, are German, I want to say. But Hans has quite the vocabulary. Actually, I have all his words written down if you guys want to see it. But yeah, Hans is a very smart lad, for sure. Very, very smart lad. All right, everyone got their attendance in the chat, people? Because I am ready. I am ready to conclude Unit 5, because honestly, people, Unit 5 is my least favorite unit of all the units. Of all the things to teach you about in microeconomics, and even macro included, I'd probably say Unit 5 of micro is like my least favorite. Not gonna lie. All right, people, let's get to it. So we're talking about two different concepts today. All right, we're gonna, start off with one thing, and then we're gonna, transition to a totally different thing. Right. So what we're talking about here pertains to perfect competition resource market, and it's sort of its own concept within it. And it's called the least cost rule, or maximizing output with the the least amount of inputs sort of situation, right? Producing at the lowest possible cost, maximizing your financial capital that you have, and using that to employ resources to produce the lowest cost, or to profit maximize is the idea. And it's going to look insanely similar to utility maximization. You guys remember that, right? How do consumers maximize their utility? You were given like $30, and you were given apples and oranges, and you had to identify what combination of apples and oranges would a consumer buy to maximize their marginal utility per dollar spent, right? The bang for their buck. Same thing here, right? We're going to be a firm, right? A business, and we're going to be choosing between two different resources with so much, financial capital, right? And how can we, buy resources to get the most marginal product per dollar spent? Right, the most bang for our buck, again, right? Sort of the same situation. How can we produce the most with the least amount of cost? The least cost rule. All right. So again, look at this. It's very similar to utility maximization, right? Instead of two goods, we got two resources. We have humans, workers, and we have robots to the left, right? So a robot, the price of a robot, or the cost of a robot, is $10, and then the price/cost of a worker is $5, right? Again, we're trying to figure out and compare and get into like terms two different resources of two different prices, right? And isolate that and try to figure out marginal utility per dollar spent. Instead, marginal product per dollar spent is the idea. So it works very much the same. So just like utility maximization, instead of giving or being given the marginal product, right? What's probably going to be more likely to happen is you're given total product. Right, you're given total product, then you have to calculate marginal product, and don't stop there, right? Some of you guys, when you were given total utility, you would calculate marginal utility, and then you would start selecting, the optimal combination of goods, right? Make sure you get it into like terms, right? Because if we simply say, oh, we're gonna hire the first robot over the first worker because the robot produces more than the worker, right? You're ignoring something very important, right? How much does it cost for that resource? A worker is twice as, or half as expensive as a robot, right? So we need to calculate, bang for our buck, right? How much product do we get produced per dollar spent on that resource? So remember, utility maximization was marginal utility over price. Here, it's going to be marginal product divided by the price, right? If we employ this first robot, let's do the first robot right now. If we employ this first robot, right? Okay, real quick before I do that, right? So again, you're usually going to be given some sort of income, just like you had with utility, and then here is the the least cost rule, right? Here's the formula. Remember, it was mu over p of good A, right, equals the MP over price of good B. Same thing, right? Marginal product of resource A over the marginal product of and price of resource B, right? Same situation. But anyway, right? So how much bang for our buck do we get with this first robot? Well, this first robot we employ, right, can produce 30 goods, right? It can produce 30 units of whatever we're talking about. And the cost of that resource is $10. So how much goods does that resource produce per dollar spent, right? It'd be 30 divided by 10. That answer would be $3, right? Or 3 units per dollar spent, right? 3 units over dollars. And then the second robot we choose to hire or to employ, right, can produce an additional 20 units, but we have to spend, not really pay, but spend $10 on that resource. So how much product do we get per dollar spent? To be 20 divided by 10 and be 2, right? And then again, how much bang for our buck? How much product do we get per dollar spent? And then here, right, this third robot, if we choose to buy this resource, is going to cost $10, and when we buy that resource, it's going to produce an additional 10 units of output. So 10 over 10 is going to be 1, and then here, 5 over 10 is going to be a half, right? This fourth robot gives us a half a unit every time we spend $1 on that resource. So once you get to this point, right, then you can compare two different resources at two different prices and try to figure out, okay, which one gives us the most bang for our buck, the most marginal product per dollar spent, right? So a human, right, you only got to pay them 5. The wage is 5 in this case, not really a price, but a wage is 5. And this first worker that we hire can produce an additional 20 units for the firm, and we only got to pay them 5. That means we're going to get 4 units produced per dollar spent on that resource, which is pretty good, right? And if you look at it right now, like, we definitely want to hire a person before we purchase a robot as the other resource, right? Because again, we get much more bang for our buck here than we do here, right? And then the next worker we hire produces an additional 15 units. That's their value they add to the firm, and the cost of that resource is $5. So 15 over 5, that worker produces an additional 3 units per dollar spent on that resource, on that worker. And then 10 over 5 is 2, and then 5 over 5 is 1, right? Again, it's basically the same thing as utility maximization, but we're just kind of flipping it a little bit here in the resource market. All right, so now at this point, right, once you calculate marginal product, per dollar spent, right, not just marginal product, don't stop there, right? Remember, you get to marginal product per dollar spent. That's when I want you to, put an income, or not income, in this case, it's like financial capital. It's like capital that the business has to spend on resources, right? Put that somewhere, right, on your paper, right? So we have $35. That's what it said. It says you have $35. What combination of robots and workers will you employ to maximize your output, right? So we have $35. I like to write that somewhere. Pick a resource. How much does it cost? Slash it out, and then get to the point where we're gonna be. Jacob's already on. He says 2 robots, 3 workers. Let's see if Jacob is right. All right. So which one are we going to employ first? Definitely the worker, right? Because the worker gives us much more marginal product per dollar spent, right? Can produce much more every time we spend $1, much more bang for our buck. We're going to employ that worker first. Now, don't forget, right? They have different costs, right? So the worker costs $5. So if we have $35 to spend on resources, right, we're only going to take off 5 from this one. So now we have $30, right? So again, we have financial capital. Let's buy some more resources. All right, which one should we buy next? Doesn't really matter. We're going to go over to the robot. We're going to buy the robot, right? Because 3 equals 3. We can go either way here. Doesn't really matter. We're going to get 3 units per dollar spent. It's the same exact as a human. That robot's going to cost $10. So now we're going to go to 20, right? And again, we sell more money. Let's buy some more resources. Which one's next, right? We're going to go buy a worker. Buy a worker. It sounds kind of weird. Because again, we get 3 units per dollar spent here, opposed to only 2 units per dollar spent over here. We're going to go with the human. Human costs 5. That's going to take our financial capital down to $15. We still have more money to spend. Let's spend it, right? Again, we can go either way here. We're going to get the same bang for our buck, either employing a robot or a worker. Let's go employ a robot to switch things up. A robot costs $10. Don't forget, right? So subtract your capital from 15 to 5. And then now we have $5 left to spend. Lo and behold, right? Remember, it always equals out, right? You're gonna employ the worker next because 2 is greater than 1, and the worker costs $5. You're gonna go exactly down to $0. And just like utility maximization, you should know if you have the answer right or wrong, right? Because these last 2 numbers have to equal one another. The marginal product per dollar spent on the robot has to be equal to the marginal product per dollar spent for the worker, right? 2 equals 2. So that's my explanation. Same thing with utility maximization, right? Because if they're not equal, that means you're going to buy more of one or the other until they equal, right? So if you have $35, the best combination is 2 robots, 3 workers. Jacob was right. And if it asked me to explain, right, my explanation would be, the equation, MP over P, A, X, R for robots, and W for workers, right? Doesn't really matter. And then put those numbers in there, right? Comma, 2 equals 2. Those are the actual values, and they actually do equal, so this is the combination. And I've spent all my income exactly, so yeah, right? Because if you get to a point where, your income doesn't exactly equal $0, right, and these don't equal, right, you did something wrong, which is nice, right? You go back and find some sort of mistake. And generally, I will tell you this, people, if you do all this work and you find that, it doesn't equal and you haven't spent exactly all your income and the two circles aren't the same number, it's probably because you didn't calculate marginal product over price. It's probably because you just did marginal product, you converted total product into marginal product, and then you started selecting resources, right? That's usually why you might have some errors, but I think it's pretty easy. I think it's just like utility maximization, which is good because it's kind of a review for that. It's been a while. But now we're just in the resource market selecting resources instead of a consumer selecting, the optimal combination of goods to maximize their own satisfaction, their own utility. All right. So that's called the least cost rule. There's been no formal FRQs that are like this, like full-on utility maximization that are set up like this, but they're sort of embedded within resource market FRQs, and you're going to see that today. The first FRQ you guys are going to do today, I think it's called John Lamb Company. I think the last question on there basically gives you, 3 of these 4 values, and you got to solve for X, or you got to solve for X, right? That's the idea. Okay, so and actually, it's probably one of these right here. It's actually this one, right? John Lamb is employing the cost minimizing combination of inputs, the least cost rule. The marginal product of labor is this. The marginal product of a machine is this. The wage rate for a labor is this. Or you got to figure out what, solve for X. What is the price of a machine, right? That's kind of, more realistically how you're going to see this concept, in actuality, right, on the AP test, right? It's going to be sort of, solve for X, here's 3 of the 4, right? And knowing that MP over P must equal MP over P. But that's that. All right, so now we're going to totally transition to monopsony. All right, so monopsony is obviously the opposite of perfect competition resource market. Remember, perfect competition resource market is many, many, many buyers of labor, right? It'd be a town where there's like 100,000 Taco Bell restaurants, right? And every worker is exactly the same. It's very, very, unrealistic, right? Monopsony is a little bit more realistic, right? I would say labor in general is much more monopsonistic than it is perfectly competitive, which is kind of messed up because a lot of people form their opinions on labor practices like regulating labor, like unions and minimum wage and things like that, in thinking that most labor is perfectly competitive. In actuality, labor is much more monopsonistic, right? So when we enact minimum wage and things like that and unions and whatnot, it sort of can form your opinions a little bit differently, right? Like whether unions and minimum wage and things like that is good, right? So a monopsony perfectly, Tyler's like GM and Flint. It's like in the middle of nowhere and there's only one school, and if you're a teacher, there's nowhere else you can supply your labor, right? There's only one buyer of labor is the idea of a monopsony. It's one fast food restaurant in a small town. It's one gas station in a small town, right? If you're good at being a gas station attendant, right? The best example is like a coal mine in Tennessee, right? Or like West Virginia, right? It's a one firm town, and if you want to work, right, there's only one place to work, and it's the coal mine, right? Is the idea. That's the idea of a monopsony. One buyer of labor. All right, so that's the biggest thing that defines a monopsony. It's different than perfect competition. Is there's only one firm hiring the labor, right? So this firm is large enough to manipulate the market. We're going to find out that this firm is going to employ less workers in compared to a perfectly competitive resource market, and they're going to pay workers lower wages than they otherwise would if it was a competitive market. So a characteristic is going to be that workers are relatively immobile, right? Because if workers can work, right, they can substitute their labor elsewhere, and they don't have to work for this monopsony, right? So is teaching in Grand Blanc really monopsonistic? I would probably argue not, right? Because if I don't want to work at Grand Blanc, I could just work at another nearby school district. But some school districts, right, especially up north, right, like in the UP and things like that, I would say teaching is much more monopsonistic, right? Because if you're a teacher and you live in a certain residence, right, without selling your home, it'd be hard to supply your labor elsewhere, So that's kind of the situation, right? It depends, right? But I would say labor in general is a little bit more monopsonistic than it is perfectly competitive. So perfectly competitive firms or workers in a perfectly competitive resource market are wage takers, right? Because again, they have identical skills. Every firm's the same. They're going to take the wage determined by the industry. In a monopsony, right, the firm is a wage maker. They determine the wage, just like a monopoly is a price maker, right? And remember, I think it was yesterday, right? We drew perfect competition, resource market, and I showed you what a perfectly competitive product market looks like. Everything's flipped. It's going to look the same way with a monopoly and a monopsony. A monopoly is the monopoly gang sign, looks like this. A monopsony gang sign is the other way. It's looking like this, all right? So to hire additional workers, the firm must increase wages, right? A monopsony can't force people to work, right? That has been outlawed quite some time ago, right? They can't force people to work, but how do you incentivize people to work? Via wages. So if you want to get more workers to work for you, right, you have to increase wages, right? You have to offer an incentive for more and more people to be willing and able to supply their labor, right? We learned that supply for labor is upward sloping. So if they want to get more workers to work for them, they have to increase the wage. So we're going to see that MRC is not going to be equal to supply, right? Just like MR is not equal to demand for a monopoly. So some examples, right? The NCAA is definitely the only firm that hires or entity that hires, amateur, sports, schools in most situations, like police departments, fire departments, like anything in a small town, really, coal mines, right? There's good examples of monopsonies, and generally it's we're looking like in a local perspective, right? Not like nationwide, but yeah. All right. So anyway, let's try to figure out, okay, what is MRC going to be? How is that going to be related to supply? Because with perfect competition, right, MRC is equal to supply, right? The additional cost of hiring an additional worker is equal to the wage rate. It's equal to the willingness and ability to supply your labor. It's constant. In this case, it's not going to be constant, right? Because then you can see, right, if we're talking, Acme coal mining, right, definitely like a monopsony, right, like a coal, mining firm, right. The wage rate of $4, no one is willing to work for $4, right? The wage rate is too low. No one's willing to work. So how do they get more people to work for them, right? Just like when we were talking about monopoly, how do we get more people to buy it? We got to lower the price. How do we get more people to work, right? We have to raise the wage, right? So we raise the wage, and we, at $4.50, someone's willing to work at a wage rate of $4.50. So the additional cost of hiring that additional worker is $4.50, right? Then we want to get a second worker to work for us. We have to raise the wage, and assuming that we can't wage discriminate, right? We're going to have to, the additional resource cost is not going to be equal to the wage rate, right? Because now the total cost is $10, right? And the additional cost of that second worker is $5.50, right? Because we went from $4.50, so now we went from a total cost of $4.50 to a total cost of $10, right? 2 times 5, right? So the additional cost of that second worker is not 5, it's actually $5.50, and so forth and so on. So you can see that the supply for labor here, right, people's willingness and ability to supply their work at these different wages, that's what supply is not equal to the additional cost of employing that additional unit of resource, right, that additional worker. So just like MR is less than demand, MRC is going to be greater than supply, right? Everything is the opposite. So remember, monopoly gang sign is like this, monopsony gang sign is like this, right? So MRC is greater than supply, right? MRC is greater than supply. Every time you want to hire another worker, the additional cost is going to be greater than the actual wage rate for that additional worker. So if the firm can't wage discriminate, where is MRC, right? The MRC is going to be greater than supply. And again, this would be the opposite of a monopoly. All right, let me take you guys over here real quick. Let me show you. Let's get this FRQ out of here. Let's put some snow in the background. All right. So again, here is a monopoly, right? Here is a monopoly. Supply equals marginal cost, right? That's what a monopoly looks like. Monopoly. This pen's really bad. And then this is a monopsony. Monopsony, right? We got supply is upward sloping, we got the demand for labor is downward sloping and MRC is greater than supply, right? Can you guys see that? Can you guys see that, right? Now remember, with a monopoly, we choose to produce where MR equals MC. That's going to be our quantity. Same thing here, right? We're going to choose to hire where MRP equals MRC, right? Same idea. That's going to be the profit maximizing, quantity of hiring workers, right? And remember this, right? Just like on the monopoly graph, we went up to our demand curve to find the price. We're going to see here that we're going to use our supply curve to find the wage, right? Do you guys see how similar those are, yet completely opposite is the idea? And then real quickly, I want to draw perfect competition in the firm, right? This is perfect competition for the firm, right, of the product market, and this is perfect competition, the resource market. MRP, right? See, everything is just turned upside down, right? If you forget on the AP test, like how to draw either of these graphs, right, just remember it's just like upside down, right? You flip supply and demand as well is the idea. But okay, let's get back to the PowerPoint because we're almost done, right? So yeah, here is a monopsony, right? Just MRC is greater than supply. What I just showed you is the reason why, right? If you want to hire an additional worker, the resource cost is going to be greater than the actual wage. So yeah, we're always going to hire up into a point where MRP equals MRC. We're not going to hire, this quantity of worker, right? Because this quantity of worker, MRC, is going to be greater than MRP. It's going to cost an additional amount greater than, how much that additional worker is actually going to bring in terms of value. So again, always select your quantity to hire where MRP equals MRC, and then make sure you go down to your supply curve to realize the wage, right? It basically says, the supply curve says, this many workers are willing to work at this wage. So why would they pay them this, right? Your supply curve is what tells you the wage rate. So yeah, right, it's just a monopoly flipped upside down, all right? And that's pretty much all you need to do. That is pretty much it. Are there any examples of monopsonies in the product market? No, yeah, monopsony is a resource market. A resource market is buyers of labor or buyers of resources, right? I would almost say like Amazon is almost a monopoly in the product market, and they're almost a monopsony in the resource market, right? At some point, like most labor is going to be working for Amazon, unless most of it gets structurally unemployed, like replaced by automation, right? It kind of seems where Amazon's going is they use a lot of automation to produce, but yeah. So yeah, you guys are gonna get the FRQ that pertains to this. If I can, do I have it on here? I do not have it on here, but yeah, that's pretty much it. And then, oh yeah, last thing I want to talk about. So all I really care that you know how to do is find the quantity of workers, where MRP equals MRC, and then find the wage rate. And then the other thing that you need to be able to do is compare that to perfect competition, right? If this was a perfectly competitive market, and we're talking about the industry, right, we would hire where supply equals demand, right? This would be the quantity of workers if this is a perfect competition resource market here, and this would be the wage rate. So remember how you got tons and tons of questions about, well, hold on, you guys haven't taken the Unit 4 test, have you? On the Unit 4 test, there's tons and tons of questions about a monopoly compared to perfect competition, right? What's the difference, compare price and quantity, right? A monopolist will always underproduce and overcharge, right? Prices in a monopoly are higher than it is perfect competition, and a monopolist will produce less quantity than perfect competition. Same thing here, right? A perfectly competitive resource market will hire more workers at higher wages than a monopsonist will. Yeah. You want me to go back to the chart? Yeah, I'll do that real quick. And then the last thing is on the FRQ you guys are going to do today, there's a question about minimum wage. I don't want to give it away. I want you guys to try that. I'd be curious to see how many students would get it right, because it was one of the all-time most missed questions in AP micro history. Was if a minimum wage was enacted on this market, what would happen to the quantity of workers hired, right? So try your best on that. I will probably go over those FRQs on stream or on Google Meet using the document camera, but I don't want to give it away just yet. But that's the only thing that might be foreign to you when you actually see that FRQ. So yeah, Jacob says, how do you do this third column again? Right? I should have put total cost somewhere. Right? So if you hire if you hire 2 workers, right? If you hire 2 workers in total, the total cost would be $10. Can you see that? Right? You got to pay each worker $5. Right? So the total cost would be $10. So our total cost went from $4.50 to $10. So the change in total cost was $5.50 over the change in inputs was 1. So $5.50 over 1 is $5.50. All right, that's the idea. Is I really should put another column of it won't let me go in here. I want to put a new column in. But yeah, that's the idea. Is remember, the find marginal is always the change in total. Does that make sense, Jacob? All right, good. All right, so when you do that, every time you calculate that, right, you're going to see that MRC is becoming greater and greater than it is in the actual wage rate. Okay, assuming that you can't wage discriminate, right? Assuming that you can't wage discriminate is the idea. Now, obviously, people in real life, right, they get different wages at most places, not all places. A lot of places you can obviously pay workers different amounts, based on work experience or education level or whatever, right? Okay. Yeah. All right, people. That's pretty much it. That is it for Unit 5. So you guys are going to be given 3 FRQs today, and based on how you do on those, right, you're going to be able to kind of self-assess and see where you're at. Now, remember, we're not going to be taking a Unit 5 test. We're going to be taking a Unit 5 and 6 combined test. So wait on the Unit 5 test. I can open up the MCs if you guys want on AP Classroom, but we're not going to take that test until next week. And in reality, that's pretty much going to serve as our final exam, right? It's going to be like your last thing you're going to do in this class, I think. All right, people, I will see you guys shortly. If you need a 5-minute break, by all means, go get yourself a sandwich, go use the latrine, and I'll see you guys very shortly.